Today I'm going to test and repair this AMPTRON Socket 7 PM-9600. Hello and welcome back to my channel. Today on the bench we have this Socket 7 motherboard. It's a AMPTRON PM-9600. I never heard of this brand, to be honest. It's a Socket 7 motherboard. It looks like one of the latest Socket 7 motherboards because it features a dual AT and ATX power supply input. It has onboard disk controllers. It features both AT and PS2 keyboard connectors. And it also features DIMM sockets and SIM sockets. This motherboard features this TX2 chipset, which I struggled to find at the beginning. But then it looks like through the RetroWeb database, I found this mention that basically the TX2 chipset is an OEM for these, how do you say, Ali M1531 or 1543. So nothing special. And looking at the RetroWeb database, again, it's a motherboard supporting both Pentium and Pentium MMX. The maximum FSB is 83 MHz. It features 1 MB of cache. I do see on the motherboard there's only one socket populated. I don't know whether you could get a motherboard with maybe 2 MB of cache, or maybe this is 215 KB of cache, I don't know. Nothing really special. I know I purchased this motherboard as faulty. I don't know what the fault is, so we're gonna test it together and see what happens. The first thing we have to do on any motherboard, to be honest, not just this one, is to make sure the jumpers are set up correctly for the CPU. The CPU I'm going to use is this Intel Pentium. It's a 90 MHz and the code here says SX968. Which looks to be a 90 MHz, of course, 60 MHz bus processor running at 3.3 volts. So first of all, we will need to set the CPU selection, which basically sets the multiplier. We are talking about the CPU here, so we need to check on DSW1, which is this dip switch here. So looking for a 90 MHz, 60 MHz, we need the switches set to off, off, on, on. With the one in the middle doesn't matter, so this is already set for off, off, on. Now when it comes to voltage selection is the DSW2, which is this dip switch here. We need 3.3 volts, so we need off, on, off, on, off, 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 on. Off, 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 on. Perfect. And that's it. The board would be ready to power up. Now, I don't want to risk my precious Intel Pentium 90. I'm quite attached to that CPU, to be honest, for some reasons. So what I'm going to do, I'm going to power it up and measure the voltage on the pins on the socket to make sure that I'm not going to fry my CPU. Okay, I've got memory plugged in. I have a speaker just to see whether by any chance there's any beep. I have my little diagnostic board here so we can see whether there's all the voltages are there. Okay, multimeter is set to voltage DC. I would say let's power this thing up, see if it powers up, if it does anything, and let's measure some voltages and see what happens. Ready to power up. 3, 2, 1, go. Oh well, something's happening. The beeper is making this weird beeping noise, which is not even there. Let's try and measure this voltage here. 4.5. That's not what I'm expecting. Right, so the first thing I want to do, I want to make sure that I'm definitely correctly set with the jumpers. And if that doesn't work, I guess it's time to have a look at the power supply section here, which is made by these IC3 transistors. We might need to take a look at that. Well, to be honest, if I'm looking at the settings here, I can set the CPU voltage between 2.2 and 3.5. I'm reading 4.5. Now, it's without a load, fair enough, but I don't think I should read 4.5 at all. Again, the higher should be, I mean, it could be 3.6, something like that, but not 4.5. So I have a feeling we might have an issue, and that could be the issue with this motherboard, to be honest. So at this point, I started looking for anomalies or shorts on the power supply circuit. Now, if I'm looking in this area, I see these three components, plus some extra inductors and capacitors, and this seem to be the components responsible for the generation of the voltages for the CPU. I see that this one is an H1084-80J as for adjustable. And this is a variable voltage regulator. It has a maximum input voltage of 7 volts and a variable output, which is between 1.3 and 4 volts. The next component is a PHD45N03, and this is an N-channel MOSFET. And finally here I have a PBY-R10, and this is just a diode. And again, I see some inductors and capacitors, which are probably responsible for smoothing the voltage to the CPU. Okay, so I set my multimeter to diode mode, and I started probing, looking for something obvious. And lo and behold, I found a short on the diode. Now, as usual, it's difficult to understand where the short is. Is it a component? Is it something else on the board? So after probing a bit around, I decided to remove the diode altogether. Motherboards are usually multi-layers, and they usually feature large ground planes. Now, a ground plane will suck away most of your heat from your soldering iron or your hot air station. So I decided to go ahead and turn on my preheating board here to help out with the desoldering, as the socket 7 is a plastic component and I really didn't want to damage it, because if I damage the socket 7, then the board is crap. At this point, I also decided to remove the MOSFET transistor as well, as again, it takes a while to heat up the whole thing, and I thought if the diode tests okay, maybe I want to check the transistor, so I went ahead and I removed the transistor as well. Once the components were removed, I went ahead and I tested the motherboard to see whether the short had gone, and no, it hasn't. The short is still here. So I didn't know what to do at this stage. Let's go ahead and check the components on my component tester. So first is the MOSFET, and the MOSFET tests okay, there's no issues with it. And also the diode tests okay too. I was a bit confused at this point, or actually a bit disappointed. You know, what do I do next? What do I check next? And then I noticed something. I noticed that the component tester, when tested the diode, is telling me that the diode is between 2 and 3, which on the diode SMD diode is the tab and one of the legs. But I was sensing a short between the two legs. So after thinking about it and looking around, I realized my mistake. I checked the wrong datasheet. So I've managed to find online the datasheet for the through-hole component. And the through-hole component has a different pinout than the SMD component. Actually, I didn't even look at that, to be honest. I, for whatever reason, assumed that the diode was between the two legs and not between the leg and the tab. I found the proper datasheet, and indeed, one leg is labeled as not connected, which on a motherboard like this probably means that the leg is grounded. So the reason I was looking at short is because I was checking ground with ground, which obviously is shorted. So yeah, I think there's nothing wrong with these components, and I've been wasting my time here. Right, I've done a little bit of poking and troubleshooting off camera, and I think I got a reasonable understanding of how this thing works. First of all, this component here, this chip here, it's a switching controller. This controller with the MOSFET, the diode, the inductor and these capacitors, it's actually a very small switching mode power supply. While this component here is just a linear voltage regulator, which is an adjustable one. So there's a couple of resistors there. I don't think it goes anywhere else. This motherboard supports Pentium MMX CPUs, and from what I can see, Pentium MMX CPUs, they are also available in dual voltage packages, which means the CPU will require 3.3 volts for IOs, but 2.8 volts for the core. So this motherboard is compatible with those CPUs. So those two jumpers here, the red ones, when they are in this position where they are right now, 2 and 3 selected, this means that the motherboard is set for single voltage over the whole CPU, while if you move them to pin 1 and 2, which is on the left hand side, they will be in dual voltage mode. Let me remove those jumpers and let me show you something. Now on the socket, basically the first half is VCC2 and the second half is VCC3. I have the meter in continuity mode. So if I'm trying to check the continuity between VCC2 and 3, the there's no continuity basically. It doesn't read anything. And what I found is that the output on my little switching mode power supply, let's call it that way, which is the output of the diode, which is basically connected to the inductor, is connected to VCC2. So VCC2 is my, let's call it switching mode supply section, while the output of VCC3 is connected to the middle pins of this jumper array. So the middle two pins are connected to VCC3. By installing the jumpers on the right hand side, I'm basically connecting VCC3 to VCC2. It's going to be the same circuit delivering voltage to both VCC2 or VCC3. But if I'm connecting the jumper on the left hand side, then I'm connecting VCC3 to the voltage regulator. Let me show you. So right now the motherboard is set for dual voltage because the jumpers are on the left hand side on pin 1 and 2, and you will see that my VCC2 is connected to this circuit, but my VCC3 is connected to the linear voltage regulator. Instead, if I'm switching the jumpers to single supply, then both VCC2 and VCC3 are connected to the same supply circuit, which happens to be this section here. In other words, in single supply mode, the linear voltage regulator is not being used. We had 4.5 volts earlier on. Now, unless it's a problem with just a lack of load, which is very possible, it means that there might be a problem with the switching supply, which this section here. Now, we know the diode is fine, we know the MOSFET seems to be fine, so either the load is missing or the controller is not working. Let's reinstall those two components and let's try and put load on these VCC, because chances are there's nothing wrong with it, and I've been chasing ghosts for the last hour and a half. Okay, I've got a little setup here to test the supply of the CPU with a little load. Now, I don't want to play with the CPU socket because I might damage it. So I temporarily soldered the pin basically after the inductor here. And basically this is going to this little resistor. It's an 8 ohm, my usual 8 ohm resistor. I set up this multimeter as a current meter in DC mode, which is something no more than 500 milliamp. Again, that's for peace of mind, just to make sure that, I haven't done anything weird. And this is going to be my voltage reading, which I'm going to read from the socket itself using this probe here. Okay, I've got everything connected, so let's give it a go and see what happens. 3, 2, 1, go. Oh, 2.2. I think, okay, I've been playing with the dip switch. So yeah, it is actually set to 2.2. Oh my gosh, I just wasted 2 hours of my time. So let's go back to 3.3 volts, which is off, on, last one. So hopefully now we get 3.3 volts. 3, 2, 1, go. Yep, we do. And we have 309 milliamp. So that's totally fine. So the noise from the speaker is, I don't know what it is. The voltage is totally fine. So I've been wasting my past 2 hours. Fantastic. But again, I don't know. Did I learn something? Not really, but I had fun. That's fine. I don't know if you had fun, but whatever. So I guess we can stick the CPU in and test this board and see whether it's actually doing something or it keeps doing this weird noise. And the CPU is in, so let's power it up. I should be able to double check the voltage with the CPU in from where I'm probing there. So let's 3, 2, 1, go. Yeah, voltage is fine, so we don't care about this. I can unplug the speaker. And yeah, there's no activity whatsoever between the CPU, the BIOS. The speaker is doing the weird noise. Before I start with weird things, I guess I want to check a couple of things. First of all, I want to remove my memory modules, just in case for whatever reason they don't work with this motherboard. So let's give it a go. 3, 2, 1, go. Oh, it's beeping more. That's weird. Let's also do I have a thermal camera, but again, can do a little chip temperature. Well, there's not much in this motherboard, to be honest. So no, I don't feel anything weird. I guess the next step would be to remove the BIOS chip, see if there's any change or of any sort. Well, the BIOS chip looks fine. It's not corroded or there's anything wrong with the legs or anything. See if we can power up the motherboard and anything changes. 3, 2, 1, go. That's so weird. What is this? Okay. Now, before I continue with the diagnostic and actually call it a day, it's a bit late here, I want to show you something which is really, really funny, at least from my point of view. Let me power up the motherboard. I'll put the microphone close to the speaker so you can hear what it does. It looks like a motorcycle. This is a motorcycle, this is not a motherboard. I know it doesn't really make much sense, but this is quite weird. So I feel the next step would be to just replug the BIOS chip, see if that changes anything. It's so weird, I don't really know what to do right now. And BIOS chip is in, let's power it up again. 3, 2, 1, go. And it doesn't make any difference. Other thing I can think of, which again, I appreciate it doesn't make sense because if it happens without the BIOS chip, resetting the BIOS probably is not going to help, but I can check. Let's have a look. The reset BIOS should be JP1, and JP1 is this one, this pin here, which oh, wait a minute. Oh, that was left in the clear CMOS position. I don't know. I wonder what happens if someone leaves that in clear CMOS position. Let's move it to the normal position and see if that changes anything, to be honest. So 3, 2, 1, go. Oh yeah, well, the noise is gone. That's a step forward. The CPU is still not doing anything. You can see there's no processing whatsoever, but at least the noise is gone, which was a bit weird. I can see the CPU is getting warm. I would say the next step would be to make sure the battery has some voltage left. 3.4, this sounds like a brand new battery, to be honest. So battery is good. Right, at this stage, I would say let's fire up the oscilloscope and start checking the usual subsets. Actually, before I even start, I want to make sure the reset line works. For that, I don't even need the oscilloscope because this little board has a very convenient reset light here that we can check together. So reset is this little, the LED bottom left, and I have conveniently attached a momentary push button to the reset line so we can test it, and we should see the LED flashing somehow. So let me power up the board. 3, 2, 1, go. To be honest, I already see that the reset starts high and then it goes low, but if I reset now, it goes high, and if I release it, it goes low. But unfortunately, there's no activity. So the reset line works, we have all the voltages, and yes, so let's move on and start checking on the BIOS itself. Right, let's start from the BIOS. Oscilloscope is on screen, and let's start with the voltage coming to the BIOS, the VCC. Power up, and this is 5 volts, so that's totally fine. Let's have a look at, I don't know, some random pins here. I don't have the pin out in front of me. It looks like this actually looks that it's doing something. This one too. Same for this one. Let's see a little bit more. Okay, well, it's doing something, but it's kind of this pulse. I don't know how much you can see that on screen, to be honest. You can probably see better from here. If I'm rolling it, you can see that it's not really activity. It looks like this is kind of this is like a square wave, and this is again, it's mostly high with some pulses down to low. And if I keep checking, they look like they're all the same. It looks like, again, I'm not an expert when it comes to that, but it looks like it's kind of in a hold state or idle state where it's obviously it's not executing any instructions. I think now I'm on the data output pins. They're basically all the same. Let me see what happens if I'm going on a data on one. I think it's one of the data lines. Let me see what happens when I reset the board. Do we see any activity? So I'm setting the oscilloscope on single trigger, and then I'm powering on. It's a bunch of data. So it's doing something for a very split second, but then it stops. So it looks like there's no activity on this thing, or very, very little. The CPU is definitely getting warm, so it looks like it's kind of happy. I would say the next step would be to check for the clock on the CPU, and maybe we also want to make sure that the CPU is getting both voltages for I/O and for the core. So check the clock, check the voltages, and maybe check that the reset line actually reaches the CPU as well. Yes, so as you can see top right, we have 60.0 megahertz. So that is correct, and then we should have an internal multiplier of 1.5 to get to 90 megahertz of the CPU. Perfect. So the clock is correct. Okay, this should be my reset line. Power up now. Well, you can see that already that it worked, but I can reset it manually through my little switch here. So if I'm clicking, it goes high, resetting, it goes low. So the reset line works and it does reach the CPU. So this is my 17 VCC2, 3, 2, 1, go. And we're reading 3.34, which is totally fine. Let's read the next one, which should be the other section, the other voltage. And it's exactly the same voltage, 3.34. Yeah, they're all 3.34. So we know the CPU is reaching, we're receiving the right voltages on both halves of the CPU, let's call it that way. So at this stage, we have the reset line, we have the clock, we have the voltages, but there's no activity on the BIOS. Well, there's no activity. I think I might want to see maybe if I can reflash the BIOS. Maybe the BIOS have got corrupted, and see if I can read it, see if I can reflash it using my programmer, flash another one if I can find one online, and see what happens. Because honestly, I'm a bit stuck here because there's not much happening, and I don't have clues at the moment on why this is happening. Right, let's have a look at this chip, and there's a label on it, so I will have to remove the label to see what type of chip it is. So this is a AESD, never heard of it, AE29F1008-15. So let's plug this into my programmer and see if he can read it, and most importantly, what it says in the code. Right, here we are. So let's select the chip, and here it is. Let's try and read the chip. Read. Okay. Okay, yeah, there is something. Let's see if there's anything. Usually there's some indication about the version either at the beginning or at the very end. And here we go. That's, well, it looks like it's version 1.10 or 1.1, PM-9600, which is indeed the version of this motherboard of the 15th of July, 1995. Now, looking at the retro web, which is the main database where you can find all the schematics, all the BIOSes and everything. If I'm clicking on downloads, there's only one BIOS version, which apparently is 15th of January 1999. So the one we have here is 15th of July 1995. So there is actually a newer version online. Now here we have the BIOS that I got from the website. Click on open. Okay, so that should... that hasn't really, still says 15th of July 1995 here. Okay, well it looks like or at least the date in the BIOS is exactly the same, so chances are this is exactly the same BIOS, but again, never mind, I'm not trying to update the BIOS, I'm just trying to make it work somehow. So this is the one which I've downloaded from the website, so let's try to program this thing. Program. Well, the verification worked, so hopefully that tells me that it worked. Just out of curiosity, I think if I reselect the chip here, it clears, yes, it clears the buffer here. So what I can do is load the file again and then just verify it. There we go, let's try and run the verify again and see whether it passes. Yes, so the chip seems to be working, seems to have written correctly the file, and again, it seems fine. So now it's time to plug it back into the motherboard and cross our fingers. So 3, 2, 1, go. And unfortunately there is no activity whatsoever. So honestly, I'm a bit out of ideas right now, because yeah, really nothing happens, and I don't know where to move from here. Right, I might have discovered something, not sure whether it's a good news or a bad news. Again, if I power this up now, it's completely dead, there's nothing on the display. And what I found that if I push this chip down, that's a BGA obviously, and I turn it on, there is something. You know, if I reset it now, it cycles through a few operations. That's kind of a good news and bad news, because again, yeah, I can try and reflow this chip, but number one, I'm still not too comfortable in reflowing, because too many things usually go wrong when I'm doing that. Number two, usually reflowing it's debatable whether it's a solution or not. One thing I'm thinking, again, this motherboard should beep without memory, but when I'm pressing this BGA chip, the code basically says it's kind of checking memory, nothing happens. Just wondering, would some memory sticks installed make any difference? I just want to try that. Let's see, again, I'm pushing here in the corner. Eight beeps, that's the missing video card. Let's try and plug a video card and see if by any chance, by applying pressure here, it actually manages to boot up. Let me try again. You won't be able to see the codes because they're behind the PCI card. Okay, 3, 2, 1, go. Right, it's doing something. And monitor, yeah, it's booted up. Look at that. Oh wow, it's happy. What if I remove the pressure from here? Oh, okay. Still happy. I know you can't see much, but I just wanted to show you the motherboard and the video. Let me show you the... Look at that, it's working. Well, that is a good thing, because it means we do have some hopes for this board. Let's see what happens if I reset it. Oh, it's still trying. Oh, it's still booting up. Look at that. The magic finger, ladies and gentlemen, I fixed it. Okay, well, that's the end of the video. Well, it didn't take long to stop booting up again, which is totally expectable. I'll inspect it a bit more. Then I guess the only potential solution for this board is to reflow the SMD chips. Well, while I was double checking things again before reflowing and things, look what I found. Oops. Yeah, oops. Oops, that's not, it's a bit attached, but not much. That's not great. Oh, look at that. Now, this is the, I think it's the cache chip. Oh, wow, that's completely disconnected. Yeah, so I'll have to reflow them all, which is obviously much easier than reflowing a BGA chip. So I need to fix that first, and then we'll move on. Okay, at this point I'm ready to reflow these two chipsets. I'm gonna do both of them because I think this one is the faulty one, but I assume that probably if this is faulty, the other one is faulty as well, or will be very soon. I'm going to use my preheating station, especially on motherboards where you have these ground planes which are sucking away the heat. It's going to be more or less impossible to just reflow one of those chips with just the hot test station, or if it is possible, it requires very high temperatures, which are really shouldn't really be used for SMD or BGA reflowing. One thing to consider here is that those chips are soldered with lead-free solder, which means that the melting temperature is around 220 degrees and not 180 degrees Celsius as the lead solder that we normally use for repairs. Well, the chips are now 150 degrees. I think this is okay. So I'm going to start with the left one first. So I'm going to apply a good amount of flux. And now it's time to start with the hot test station, and also keeping an eye on the temperature with your infrared thermometer. Right, the chip is now reading 230, so that's okay. Be honest, my hand's a bit shaky at the moment, so I don't want to touch the chip because I'm definitely gonna misplace it. And now I'm gonna do the other chip. So that should be enough, and that's it. Again, I totally appreciate I should have nudged the chips to make sure they were floating. I tend to get a bit nervous in these moments, especially on something this is kind of working, so I'm trying to repair it. And my hands were not the steadiest I could get. So I totally felt, had I touched the chip, I would have totally misplaced it. So I just trusted my thermometer, which was giving me pretty much an accurate temperature, and I'm confident that I managed to reflow those chips. Right, I am ready to try. I haven't tested it myself off camera. Let me say I'm not holding my breath for the result. Right, I have the diagnostic board here so you can see whether anything is working. I'm not touching anything. So we are ready to power up in 3, 2, 1, go. Whoa, 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 whoa. Something's going on. Look at that. It is working. It's working, and I haven't touched anything. I'm not pressing on the chipset this time. Amazing. It's actually working. Yay. Well, again, I've been pretty unsuccessful when working with SMDs. So seeing this, to be honest, is quite a reward. It is quite a reward. Okay, well, I guess it's time to test the thing and see whether everything works. So let's get into the BIOS and let's see what we got here. Okay, let's, well, first of all, let's auto-detect the hard drives. That's perfect. A floppy is not installed, otherwise it would look for a floppy. There you go. I'm not gonna play with timings and stuff at the time being. Again, it's not really the purpose of this video, and to be honest, I'm not really too experienced when it comes to that. I'm not Necroware. Necroware knows everything about BIOSes, like inside out. I'm quite envious when it shows us all those behind the scenes about BIOSes. It's pretty amazing. Actually, let's load the best performance settings. There you go. So let's save and exit. Yeah, I can, got some video corruption here. But I'm wondering whether this is the video card, which this video card is kind of known for being a bit dodgy, but I've never seen this before, to be honest. Well, let's try with a different video card. It's nothing special, it's an S3 Trio64V, but it's a PCI one. Okay, no, that seems to be working. Okay, that is good. Let's do some tests. Okay, this is what we get. To be honest, it doesn't really see this as Pentium because it's shown as Intel 486DX, 131 megahertz. Here on system information, the Pentium 90 is displayed properly. And even for running a benchmark, everything looks okay. I have this computer 285 and it's compared to a Pentium 66. This is a Pentium 90, so it looks okay. And memory test is passing. This is obviously also telling me that the system is working correctly. Board tests are passing as well. And this cache check is also reporting that the cache, it is working fine. Well, everything seems to be working. I can definitely see that the cache is working. I'm getting a 6.6.7, which is consistent with, it's just below the Pentium 133, so that's what I'm expecting. There we go, the result is 2,134 game ticks in 1,459 real ticks. Now, can someone please explain me what those are? I mean, where are these coming from? Game ticks, real ticks? Is that actual? Who invented those? I've never seen them anywhere else. So here we go, this board seems to be working totally fine. I totally enjoy the troubleshooting, starting with that weird motorcycle-like noise. I thought this board was completely dead, but hey, we managed to fix it together. I really hope you enjoyed the video. Please consider subscribing if you like what I'm doing, and I hope I'll see you soon on my channel. Meanwhile, as usual, you have a great day. Thanks for watching, and see you soon.